So today we get to chat about our friend Pythagorean Theorem Converse. Converse. So our first skill that we want to look at is, first off, can we determine triangles? So this part is actually a review. You've already seen this. Given two lengths of a triangle, 5 and 8, what are the possible lengths of the third side? There we go. Good. So when we consider this, if I were to put these two sides together, a 5 and an 8, and open it up as big as it can get, it doesn't make a triangle, but it almost could if you just slightly close it a little bit. So that means its upper bound is 13. The largest the other side could be is almost 13, so that's why we say less than. Then the lower bound would be as if I closed the mouth of those two sides, and in that case, the almost lowest you get is 3. So there's an infinite number of choices. It could be 3.1, 3.01, 3.001, 3.00001, etc. However, it is bounded by 3 and 13. Yes. With each one of these, we wanted to figure out if they can even form a triangle. First off, can they form a triangle? Then second, what we're going to do is once we know they can form a triangle, we want to give it a name. Not like Jeff or Hafiz. We actually want to say isosceles or obtuse or something like that. So let's take a gander here. Can these two puppies on number 1, can a 5, 4, 3 form a triangle? And the answer is, remember, if you add the two smaller ones together, it has to be bigger than the third side. So in this case, because 3 plus 4 is bigger than 5, we know, yes, it is a triangle. It can make a triangle. So first part is, all we're doing is adding stuff together to check. Yes, this is review. Okay, how about this? What about number 5, 5, 10, and 15? Can these three numbers form a triangle? No, because when I add the two smaller together, I do not get it to be greater than 15. It's not greater than 15. It equals 15, so therefore, if anything, it would just make a segment like this, a big segment with a 5 and a 10 and a 15 on top. All right, take a moment. And now let's get to the bulk of what our day is going to take up. We're going to talk about our friend, the Pythagorean converse. And this is not in pure geometry language. This is just in things that you expect. I do want to point out to you that C right here is not hypotenuse, because we don't know if it's a right triangle or not. C has to be the longest side. Longest side. So make sure you put that in there of a triangle. So first off, we have a triangle. Second, we choose the longest side and we put it there in isolation. Okay, so this is how it works. If C squared is equal to A squared plus B squared, and I'll tell you in a moment why we switch those around, then the triangle is a right triangle. So conceptually, we have this situation where we have the C squared, A squared, or C, B, and A. And now notice that what will happen is we will end up getting a right situation here. Now, what if I were to expand it? Let's make C a little bit larger. Let's make C a little bit larger. And keep A and B to be the same. Notice what happens if C gets larger and A and B have to remain the same size. What kind of angle is this puppy right there? It's going to be obtuse. Good. So notice what we did. The reason why I'm putting C squared on the left side is so that the greater than symbol, if C squared is greater than the sum of the squares of the other two sides, then the triangle is obtuse. So you see the logic there? Greater than obtuse, kind of melds well. So what would you say for the last one here? All right, so if C squared is less than A squared plus B squared, then the triangle has to be a cute triangle. Oh, it's such a cute triangle. And that situation would look like this. Here's C, a little bit more shrunked, but then in order to compensate, A and B have to be squashed, pushed outward like that. And that's not to scale, but clearly what happens is that every single one of these angles is going to be acute. Yes. All right, so let's take a gander at this. Tell whether the triangles are right. So this is simply a yes or no question, right? Just a yes or no. So we're not categorizing, it's just yes or no. So all we have to do is test it. Of the three, this one looks to be the longest, and by numbers it is numerically. So 65 squared, and I'm going to put a question mark there. Is it greater than? And then we put the other two there, the 33 squared plus the 56. Good, so after we plug it in, the answer now is yes, it's a right triangle. That's it, just yes or no for this problem and these problems here. So take a moment now to, well, how do we attack this one? So let's walk through this one because dealing with radicals and the squares might sound a little complicated. So I am going to take the 16 and square it, isolate that. Question mark equals, then I bring down the 10, square it. And then I'm going to say 2 radical 38. Now watch what I do. I'm going to put the whole thing in parentheses and square it. Because I'm not just squaring the radical, I'm not just squaring the 2, but I'm squaring both of them. So when I work through this one here, I get 256 right there. I get 100 right here. And what do I get here? Well, just to show you real quick on the side, what happens is the 2 has to be squared and the radical 38 has to be squared. Now, the 2 squared is 4, and the 2 and the radical and the square annihilate each other. So it's 4 times 38. And then we get our number 152. So that's what's going to be here, 152. Notice I'm still putting a question mark right here because I don't know if they are equal. Well, 256 and then 252, and the answer is not equal. So at this point in time, we simply just say, no, it is not a right triangle. Let's take a gander at this next example where we're going to decide if they can represent a triangle. So first, is it a triangle? Then second, we're going to classify that triangle. So we have to do 2 separate equations. One equation is just to figure out yes or no, it is a triangle. The second one is to use the Pythagorean converse to figure out what type of triangle. So 2 separate equations. Question. So 2 things. Let's figure out if it is a triangle, yes or no. So first, is it a triangle? I'm going to take the 2 smaller sides there. 28 plus 40 is greater than 48. So first off, yes, it is a triangle. Now, so that's part 1. I determined it was a triangle. Part 1. Now part 2, what type of triangle? And this is where Pythagorean converse comes in. Pythagorean converse comes in. So we have to determine what type it is. So I'm going to take the 48 and make that one my C, so 48 squared. I don't know if it's equal right now to the other 2 squared. So I'll just keep that there and replace it when I get to the very end. So we substitute there and note, I'm still putting a question mark, I don't know. Now we add those together to get 2304. And now at this point, I'm going to erase that because I could use a symbol there. So in this case, the C squared is less than. So my conclusion, first off, part 1 says, yes, it's a triangle, and part 2 tells me that it is an acute triangle. Yes, acute triangle. So that would be my answer. Same idea over here. First off, I determine if these 2 add up to be greater than, and in this case, I'm going to get 17.9, which is greater than 13.9. So my first part is yes, it is a triangle. Now I take the longest side, the 13.9, I square it, and I see how it compares to the sum of the squares of the other 2. So now we do the squares, and I bring down the 193.21 equals, and it actually doesn't equal, so 181.33 is what we get. And we see here that the 193 is greater. So now my conclusion is this: yes, it is an obtuse triangle. Yes, it is an obtuse triangle.